Thank you very much. I cannot convey exactly how good this event has been for me and how happy I am for being here. I'm gonna tell a couple of things about myself before explaining why I'm doing this work. So I did my PhD in AI in Spain. I did my academic career there. I was working in what people sometimes call symbolic AI or reasoning models. It is this kind of technology where you actually get a solution and you know that it works, right? This is everywhere. So trends don't clash into each other on things like that, but we don't see it, right? There were revolutions there that we didn't see. And then I moved to Montreal, where I started to work in the industry using a language model, using NLP, language processing, and machine learning for the first time. So I have this sort of double background. And then living in Montreal also was a challenge because everybody was doing this kind of model. So I'm gonna talk about this work about an agent that is solving a task, a concrete task, right? This was a paper we published, and I'm gonna use this as an excuse for going back to some concerns that we share, including, by the way, ending in sovereignty and self-determination. This is based on a paper we collaborated. So first, a couple of concepts. These days, people are talking a lot about agents. But so this is an old word, actually. This idea of AI is all agents was popularized by this textbook. And the idea is that all of the things in AI that we don't know what AI is something that is a program that does something, right? It classify images, or it generate text, or it make plans. My definition of an agent is something that chooses an action in a word, and we need to define what is this word. And then the agent gets to live there. So it pays the consequences and others. So depending on the word and depending on the others, then we have different configurations. Sometimes it doesn't matter, right? Sometimes we have a program that classifies cat versus dog, and then it just says cat, and then oops, or right, and then, there's no consequence. But if that program is actually generating something that this goes to the internet and somebody published that, then we live in the consequences of the choices of that software that somebody put there. So it's very important to think about the consequences of this choosing. And we are the humans. Humans are the ones who decide how far away these consequences go. So in a sense, all programs can be an agent. We put them there, and then we live in this new world. All of them, right? This is one aspect. So I think that AI technology in general is about creating this agent factory. I have a method for doing image classification. And then how quickly I'm able to deploy this for distinguishing cat versus dogs or cars versus bicycles. If I can do a lot of these things, I have the technology. And then, of course, then I have this method that is scalable, like I repeated multiple times. And then it also, for this method, it depends the kind of problem. So sometimes the errors are cheap, and sometimes they are very expensive. For image classification, it might be cheap. For advertising, it's cheap. For generating summaries of things that people use language model for, it can be very expensive, right? They can be a factual mistake. So this aspect is very important. They might be not trained for about this mistake, but they might happen nevertheless. Then there is this, in general, history of AI that started, like, by the way, for funding and grants. This is tension with this precision of the answer that is more the reasoning part, and this sort of a statistical approximation. And there are like two fundamental things. There is in the background an image of two lungs, a bit too light there, but this idea that AI has these two lungs. And current AI is about generative AI that is all learning based. Therefore, everything is a data set. A data set is a set of the things of the same type. And any kind of structure, it has to be lost for being able to learn. Otherwise, there are no data sets. Everything is unique. Right? That there are no data set of humans. There can be data set of names. Each human is totally different. And then for learning, you need to forget the nuances, and therefore they have to hallucinate, because this is exactly what they do, right? So then, this is just for a couple of concepts. Then we have this one of these benchmarks we were talking about. It's called Alfred. We have this agent living in a simulator, right? Imagine it's like a video game for an agent. I open the eyes, and then it listens to an instruction in natural language, and then it looks around, and it needs to do actions in the simulator until it solves a task. This challenge was introduced because there was this idea that when you do learning, if you have to do many actions, there are so many tiny mistakes and you end up failing. So people said, okay, let's do something that is hard to do. And then on the right, we don't see many details, but this is basically one of the samples. You have this room, and then you have this instruction book. Put again a clean soup. There are sometimes instructions text, and you are supposed to live there. So these agents are to be living there forever, like a Roomba is only, vacuum dust. for the rest of the lab. And so our solution was to do a combination of these two methods. And there is a video here, the first video, please. There you go. So this is what the agents see, right? You tell them, hey, I need a glass of water. So I need to walk around. I've never seen this kitchen. You know, look up, look down. Oh, this is a bottle. This is water or no, etc. Okay, let's switch to the slide. So now I'm not going to get into details here, but the most important thing is that what we did was use models that existed for perception. I'm going to look at the objects here. I'm going to look for far away things. And then I'm going to make a combination of these things to be able to reason about it. And this bridge from perception into reason is something that I'm going to keep talking the rest of the talk. I'm not going to explain how it works. I'm just going to say that there is data, point, and pixels on the polar part. And we turn that into whether there is a cup there or not, or whether I saw a counter or not. And then because I see that, I can think, well, I have a cup, I don't have a cup, can I actually do this or not? And then we interact with the environment. In this case, this agent only lives in this simulator, so there are no consequences. Except that every time it turns around and tries to grab something, you know, it's spending time, and it might be a mistake it could get in other simulators could get stuck. So this is a general idea. So this is done in what we propose. And if you were trying to do this only using data, you would have a single box receiving all the data and in principle generating the action, right? That would be the other approach that is not working as well as this one, for reasons that I'm going to mention in a sec. So here we have a part that is about machine learning for vision. There is a part for natural language because somebody said something in text and I turned that into a symbol. And there is this internal reasoning system that is actually creating a complete solution that is guaranteed to work. So this planning part, what it is, just a quick video for just as a motivation. You can show the second video, please. Okay, so this here, this is a modular printer, and if one of the sheets of paper, there's a plan for them for they should pass whether they have color or not, right? So this was a project made by Xerox PARC for creating software for a modular printer. You put the printer together with elements, and the printer automatically construct plans for what to put in. This is working in real time. So this was made for an actual print. And it's extremely precise because, of course, you need to avoid jumps, etc. So this is kind of things that you could do with planning. It can be extremely fast. Next slide. So what we do basically, we start with this perception. Every time you move around, because you are in a location, to start to build this map of this that you saw somewhere. Oh, yes, I saw a cup over there. I saw the sink over there. And finally, you realize, oh, I got this glass. I put the water. And you are able to do the plan. So you keep doing this iteration, and the core thing there is this planner that I just mentioned. I'm just going to flag, this is the sort of thing you should pay attention to. I just saying that there is a logic representation behind, and there are some concepts like type, right? The objects, action. There are concrete things that have a specific meaning. This is not data as usual. It's a concrete relationship, and it's going to allow us to do things in a different way. So I'm getting here now to the key point. The key point is that this relationship allows us to make distinctions and to be careful about it, right? Somebody said in this instance there is a mistake on purpose that please put water in a cup. And what is a cup? Well, maybe in this context, actually probably a cup, people in the kitchen, so maybe it's safe to say that it's a cup. And the way we're reasoning about it, there is a concrete cup we are talking about. And then in the perception, when the agent is looking in what direction, there is a cup there, right? And maybe there are two of them. I need to think which one of them we are going to use. So this idea of relationship, I think I can move. This idea of the relationship, then I can use for doing benchmark. This is related with the question of benchmarking that was mentioned before, and also with the idea of the organization being able to challenge something. One of the big problems we have is that the companies are making the benchmark. Sometimes they have privileged information for doing the benchmarking, and they tell us what the problems are supposed to be and how to evaluate them, right? So we should be able to probe into these models and to test multiple situations that are of interest of us. What happens if half of the people don't have access to the technology, or they have access, it's more expensive? Can I test that and simulate the effect of that? So we have this a huge asymmetry of problems. And then this idea of making the relationship explicit is actually going to that direction. And then I'm going to go to the takeaways. I'm done here. So a couple of things. We should be able to test robustness. because otherwise we don't own the problem. And this is related with the self-determination, right? But this is a problem not only for, for the society, it's also a problem for business. There are many AI projects working because the product managers are told, yeah, we tested and it's working, and then they try to deploy the thing and it's not working. And then enabling this business, solving this business problem that would allow us in general to do this more concrete governance as self-determination. We should be able to ask the model and for testing and to stress them. So if we ask for governance, we should be able to provide interfaces so people say, let me try all combinations of people in locations in Brazil with different capabilities at home. Is it holding? Then can we do this? And in that allows a concrete way to implement this subsidiarity, in the sense that it doesn't make sense to talk about subsidiarity if there is a huge asymmetry of power. We need to be able to say something concrete about it. Thank you very much.